All right, so last week, okay, we went over how to write the names for both ionic and molecular compounds. Okay, for molecular compounds, writing the name is really easy. We just have to put in prefixes according to the number that's in the formula. Okay, for ionic compounds, it's still relatively easy. We write the metal first, we write the non-metal second, it ends in I. If the metal has more than one possible charge, then what do we have to put in the name? Roman numeral, okay, and we have to check the charges to make sure we do that right, okay. If there's a polyatomic ion, then we have to write its name according to the way it's written in the table of polyatomic ions. When we're writing formulas for molecular compounds, that's probably the easiest thing, okay. Writing a formula just means writing out the symbol for the element and putting the appropriate number beside it according to the prefix, okay. If we're doing that for ionic compounds, then we have to write the symbols for the metal and non-metal, write the charges, and do the drop and swap. Okay? We reduce the ionic compounds if we have to, and we put brackets around polyatomic ions if needed. Right? So we'll kind of go through kind of one example of each one of those situations here, and then I'm going to have you practice some on your own. Okay, so our first one here, okay, if we're doing this, guys, and this one would obviously be writing a chemical formula, okay, the first thing we have to decide is this compound ionic or is it molecular? Okay, the way we do that is we look for a metal. If there's a metal in it, it's ionic. Right? So is this compound ionic or molecular? It's ionic, okay? Because calcium is a metal. All right, so calcium is a metal, so we write the symbol for calcium, Ca, and its charge, which is 2+. Then we do the same thing for what it's with, which is phosphide. Okay, phosphide's symbol is P, and the charge on phosphide is -3. All right, now I do my drop and swap. The purpose of the drop and swap is to make sure that all the charges balance out, that I have the same number of negatives and positives, okay, so that my net charge is 0. So I drop the 3 and I swap it over to here. Okay, I drop the 2 and I swap it over to here. Now I've got +2 times 3 is +6, -3 times 2 is -6. My charges work. My formula is good. Right? Not that you have to double check that every time, I'm just illustrating. Okay? Questions on that first one? Okay, number 3 has a Roman numeral in it. Okay, so we would only ever see Roman numerals attached to metals, so this is also an ionic compound. First thing I have to do, write the symbol for manganese, which is Mn. Manganese can be a 2+ or a 4+. Which one is this? It's the 4+. That's what the Roman numeral is there to tell me. If you see a Roman numeral, it doesn't mean there are 4 manganese. It means the charge on manganese is 4. All right, so I write 4+ up here. And it is with oxygen. Oxygen is always -2. Now I drop and swap. So I drop the 4, I bring it over here. I drop the 2, I bring it here. All right. What should I do before I'm finished? Reduce. Okay, ionic compounds always get reduced to their lowest terms. Okay. So this should go to 1 and 2. Okay, so does this still work out? I got 4 positives and 4 negatives. Still good? Question?
Can you simplify molecular compounds?
You cannot simplify molecular compounds. That's a good question. Okay, we don't simplify molecular compounds because we're told with the prefixes how many of everything there is, and because they're not balancing charges. They're sharing the electrons instead, so we can't reduce it now. Okay, let's look at number 8 because it's a little bit different. Okay, ammonium sulfide. Okay, there's no element called ammonium. Where would I find it? right, it's in the table of polyatomic ions. It is the only positively charged polyatomic ion, which means it behaves like a metal. Okay, it's just one of these weird situations. Okay, ammonium is NH4, and it has a positive 1 charge. So it's like sodium and hydrogen, and anything else has that group 1. Okay, and it is with sulfur. Sulfur is always -2. Okay, now I have to drop and swap. So the 1 that's on ammonium drops and goes over here, but we don't write 1s. Okay, the 2 from the sulfur drops and swaps. What do I need to do? With brackets around it, right? Okay, so now I've got my formula for ammonium sulfide. That's as tricky as they get for ionic compounds. All right, so that's covered all of the situations that we talked about for ionic compounds. It's covered Roman numerals and what they mean. It's covered just normal binary ones and ones with polyatomic ions. Okay, so we've kind of done one of each. Now, we also need to look at molecular. So we'll look at number 15. Okay, how do I know that number 15 is molecular? 2 ways.
Has Y and N.
Right, it's got prefixes in it, and we only use prefixes for molecular. And it's also made up of 2 non-metals. Okay, so definitely molecular. So this is diphosphorous. So the symbol for phosphorus is P. The number for di is 2. And it's with pentaoxide. So O and penta means 5. And I'm done. Okay, is that ringing a bell for everybody? Okay. I would like you to do all the ones we haven't done between 1 and 20 for right now. Okay, then we'll go over some ones that go the other way, where I'm giving you the formula and you have to write the name. Okay, so let's work on those for now, and then we'll go over them together. Okay, so we're going to go and just review a couple of these ones here that are the other way. Okay, so we'll start with something easy like number 3. Right? Is number 3 ionic or molecular? It's ionic. Lithium is a metal. Okay, so if it's ionic, then I'm going to follow the ionic naming rules. I'm going to write the name of the metal unchanged, lithium, and I'm going to write the name of the non-metal, but change its ending to "ide." Lithium iodide. Do I need a Roman numeral? I do not. Lithium only has 1 possible charge, and it's +1. Okay. Have a look at number 4, because number 4 is also ionic, but has a polyatomic ion in it. Okay, we still follow the same naming rules. We write the name of the metal unchanged, so calcium. And then we write the name of the polyatomic ion exactly as it appears in the table of polyatomic ions, so calcium sulfate. All right, and then let's look at a molecular one. So let's look at number 8. Okay, so on number 8, I've got 2 nonmetals, carbon and oxygen. So I write the first nonmetal with its name unchanged, and then I change the second one to "ide," but I also have to put a prefix on it because this is a molecular compound. What's the other one? Where's the... Okay, 28. Okay, let's have a quick look at 28 because 28 is an ionic compound, but it's going to have something special in it. All right, so I've got Pb, which stands for lead, and S, which stands for sulfur, so I'll change it to "ide." But lead can be a 2 or a 4+. So I need to figure out which one so I can put in the proper Roman numeral. So as before, we look at the non-metal. Okay, sulfur always has a -2 charge, and since there's only one of each, what's the charge on lead? +2, right? We have to make this balance out to 0, okay? Since there's only one lead to balance off these two negative charges, the charge on that lead must be +2, and I write in Roman numeral 2 beside lead. Okay? All right, now, I would like you guys to try. I'm going to circle a bunch in red here. There's already some circled. So just circle them on your sheet or write down the numbers that I want you to do here. Okay, so 5, 11, 15, 17, 19, 20. Okay, so 11, 15, 17, 19, 20, 23, 25, 27, we already did 28, okay, 30, 31, 32, 33, 37, and 38. All right, so any of the ones I've got circled there. So going back the other way, 38, 37, 33, 32, 31, 30, 28, 27, 25, 23, 20, 19, 17, 15, 11, 5. Okay, so those are the ones I want you working on right now. We'll go through those together in a little bit. Okay, let's look at a few of these here, guys. Okay, so for number 5, okay, we've got an ionic compound. Aluminum is a metal, bromine is a non-metal, so we don't need any prefixes. Okay, this is just going to be aluminum bromide. Don't need any Roman numerals because aluminum is always a 3+ and has no other possible charge. Okay, we're looking at number 11. This is that special case again, the only positively charged polyatomic ion, and the reason I always put it there is because if people see a compound starting with a non-metal, they automatically go to its molecular. Okay, this is one of those ones that you have to look at very carefully because it obviously has more than 2 elements in it. Right, so this stuff will be ammonium chloride. Okay, so ammonium is one of those ones we really have to be on the lookout for. Okay, for number 15, we have another ionic compound because we got a metal and a polyatomic ion. Okay, so we'll follow the ionic naming rules. So aluminum, and this is going to be hydroxide. Okay, questions on that one? Don't be afraid to ask, guys, as we go. Okay. All right, number 17, is that ionic or molecular? It's molecular. Both nitrogen and oxygen are non-metals, so this one is going to need prefixes. Dinitrogen trioxide. Okay, number 19, we've done one like that already. Okay, that's molecular. It is nitrogen dioxide. Okay, number 20, is that ionic or molecular? It's ionic. If hydrogen is listed first, it's behaving as a metal. And it's another reason why I picked that one, is people see hydrogen, they think it's a gas, so they think it's not a metal, but it is. Okay? It is a metal even though it's a gas. Okay, this stuff will be hydrogen sulfide. And then for number, how many people are done to 23? Okay, so for number 23 here, okay, we've got an ionic compound because potassium is a metal, so this will be potassium nitride. Okay, no prefixes because it's ionic. Number 25, Okay, also ionic, magnesium is a metal, so this will just be magnesium fluoride. No Roman numerals needed there. Okay, number 27, okay, we've got aluminum and oxygen. So aluminum's a metal. Aluminum oxide, no Roman numerals needed on that one either. And then we got a bunch that do need Roman numerals. How many people are to number 30 and onward? Okay. How many people are done all the way to 39? Okay, so I'm going to do 2 of these and then I'll give you guys a couple more minutes and then we'll go through the rest. Okay, so for number 30, we've got iron and oxygen. So we'll follow the naming rules, iron oxide, but then we have to figure out what's the charge on this iron. We always look to the non-metal. Oxygen's always a -2. There are 3 oxygens, which gives us a total of 6 negative charges. That means I've got to get 6 positive charges from 2 iron atoms. 6 divided by 2 is +3. So this is iron 3 oxide. All right, similar logic goes for 31. I'll do this one and then I'll give you guys a couple more minutes on the last ones here. Okay, it's mercury and chlorine. So we'll write it as mercury chloride. Okay. Mercury can be a 1 or a 2. Okay, so it's we got to look at the chlorine. Chlorine's always a -1, and there are 2 chlorines. So we got 2 negatives. That means the mercury must be the +2. Mercury. Okay, I'll give you guys a few more minutes, then we'll go through the others. All right, let's look at the last few here. So for number 32, also ionic compound, we got copper and fluorine. Okay, so we go about the normal naming rules here, copper and fluoride. But copper can be a 1 or a 2. Okay, fluorine's always a -1, so that gives me 2 negatives. That means copper has to be the 2+. So copper 2, fluoride for 32. And then for 33, we've got tin and fluorine. Okay, so we're going to have tin fluoride. And again, fluoride's always a -1, so that gives us 4 positive charges, or sorry, 4 negative charges, which means that our single tin atom must have a charge of +4. Okay, questions on any of those? Okay, those are probably the trickiest ones. And then for 37 and 38, okay, so we've got carbon and sulfur. Those are both non-metals. So we've got carbon disulfide. Remember, we don't put mono on our first one. And then for the second one here for 38, we've got phosphorus and sulfur. Again, both non-metals. So this will be diphosphorus. Okay, pentasulfide. Okay. Questions on any of those? How are we feeling about these? Okay, so here's the thing about naming, guys. Naming is the fundamental skill you need for chemistry. If you cannot write names or chemical formulas, it will snowball from here. Okay? Because if we can't write names and formulas, then we can't write chemical reactions. We can't balance chemical reactions. We can't predict chemical reactions, and we can't do mole equation calculations. Okay? Like, this is learning to walk for chemistry. Okay? If you can't learn to walk, you will never run, you will never jump, okay? You will never do any of those things. So we need to be able to do this single thing. It is the thing that everything else in the unit builds on. So if it's something you're struggling with and you're just too shy to say so, come in and see me for help at lunch, okay, or after school or before school, because we absolutely have to be able to write formulas and names properly. Okay. All right, I'm going to give you guys about a 5-minute break here, okay, within the room, and then I'm going to have you work on something else here that's a little trickier.